Hello, my name is Alejandro. For exam number 5, I'm going to be working with homework 27.1. With me, I have my tablet, my pen, and my calculator. Let's begin. Part, part A. An electron charge negative 1.60 um, times 10 to the power minus 19 C move at 2.20 times 10 to the power of 5 meters per second through a uniform 1.75 T magnetic field that points in the plus y direction. The velocity of the electron lies in the xy plane and is directed at 40 degrees to the x-axis and 50 degrees to the y-axis. Find the magnitude of the magnetic force on the electron. Okay, what we need to find is the magnitude. And for that, we have an equation. Magnitude of the magnetic force on the electron is gonna be given by charge. Okay, let's find out all the information is given to us. Electric charge is given to us. V is also given to us. Magnetic field is also given to us and is 0.75 T. And is pointing on the picture. Velocity lies on the xy plane. And the angle is gonna be 50 degrees because it's the one that goes on the magnetic field, which we know is in the plus y direction. With all that information, we can just plug it on our formula to find the magnitude of the magnetic force on the electron. We have everything we need. This one is positive now. We're going to be working with the absolute number. B I have 50. Let's see. 76. Multiply for that. That's the answer of the magnitude of the magnetic force. Let me double check. Yeah, that seems about right. Okay, let's do B. Find the direction of the magnetic force on the electron. Okay, without doing calculation or without having to do the right hand, we can do this. If we know that that a particle is moving through the S1 plane, um, and we know that the magnetic field direction is gonna be the Y. Uh, the direction of the magnetic force we have to be perpendicular. Since an electron is always negative charge, we know it's going to be on the z-axis, the z direction. So it will be this one. Okay, part C. A sharp particle moving in the presence of 0.750 T magnetic field experiences a magnetic force of magnitude 2.50 times 10 to the power of minus 10 Newton. The particle is moving at 1.95 times 10 to the power of 5 meters per second at an angle of 36 degrees to the direction of the magnetic field. Find the magnitude of the charge of the particle. Okay, for this one, we're going to use the same formula, even though what we need to find is the charge. Formula we're going to use is and let's figure it out what it's given to us. Moving magnetic field. Magnetic field is given to us. Magnetic force of magnitude is given to us. The particle is moving at 1.95 direction. We need to figure it out. Angle of 36 degrees. In the direction of the magnetic field. Find the magnitude of the charge of the particle. Okay, angle is gonna be 36 degrees. Is on the direction of the magnetic field. Okay, I think we have everything we need. Well, first we are gonna rearrange because what we're looking for is a charge. Um, Okay, let's plug in the values. Fifth. Mm. Okay, we need to figure out the sign of 36. Roughly, okay, we calculate. I think that's the answer for part C. Let, let me double check. Yeah, that's all right. Okay, okay. Let's move on to exercise number 3. A particle charge positive 3.20 times 10 to the power minus negative 19 C with velocity v equal 3.75 times 10 to the power of 5 meters per second is in the presence of a B field with only a C component. The magnetic force on the particle is 2.10 to the power of 10, 2.10 to times 10 to the power of minus 15 n and on the y direction. Find the magnitude of V. Okay, we need to find V. For this one, we're going to use the same formula that we used before, which is so let's see if we have everything we need. Particle charge is given to us. And we know is 320 Well, it says it's moving on X. Um, B, we need to find the bond, which is the field. We know this moving, is pointing. On C. We also have here the magnetic force on the particle. Is magnetic, we need to find the magnitude of B. Okay, okay. The only thing that we need here is not given to us explicitly. It's the angle, but we can figure it out. We are told that it's moving at um, the field is pointing on C. So we can deduce that the angle is 90 degrees. Let's plug in everything we have here, or no, before that, let's rearrange for what we need to find, which is the field. Mm, okay. Now we can plug in all the values. You know, the sine of 90 is 1. Um, yeah, let's calculate. This is the answer. We double check. Yeah, I believe that's correct. Okay, part E. Find the direction of V. Okay, we know it's moving on C, and the field is pointing. It's moving on S, and the field is pointing on C. And we need to find the direction of V. Okay, the force has to be perpendicular. The force has to be perpendicular. Okay, yes, it's given to us here. The force has to be perpendicular. For it to go straight and go up, okay, the force has to be perpendicular. And for it to go straight, it means that the field will have to go up. The field will have to be, the magnetic of the field have to be on the positive. Let's do number 4. Yeah, I did this one right. Yes, I believe so. If there is a force on the side and it move forward, it means that there is a field going up. That's what it means. Okay, we are ready to move on. Number 4. Uh, Part F. Highly ionized iron atoms are found in the sun's outer atmosphere or corona. One such ion has lost 13 electrons and so has charge positive 13e equal positive 2.08 times 10 to the power of minus 18c. This ion experiences a magnetic force of 2.30 times 10 to the power of minus 15 Newton when it moves at same point 30 times 10 to the power of 3 meters per second in the SC plane. 36.9 degrees from the x-axis and 53.1 from the positive z-axis. The magnetic field is in the positive z direction. Find the magnitude of the magnetic field. Okay, this one. We need to find the magnitude of the magnetic field. That will be B. Let's see what is given to us. For this one, we are going to use the same formula that we have been using along this test. It's going to be okay. Charge is given to us. Magnetic force is given to us. Uh, P is given to us. And the direction is in the SY plane. No, a mistake. Okay. And the magnetic field, which is what we need to find, we know is in the, that means that the angle that we are gonna use is gonna be this one, 53.1. I believe we have everything we need to do this one. Let's rearrange because what we need to find is the magnitude of the magnetic field. Uh, uh, yes. Charge is given to us. Everything is given to us. And we figured out the angle. Okay, let me double check, make sure I got everything. Let's calculate. Yes, it will be roughly 0.80. Okay, and that will be part F. And part G, find the direction of the force on the ion. Okay, direction of the force. Okay, we know it's moving. We know the magnetic field. Magnetic field is in C. And it moves on the XC plane. We know the force has to be perpendicular, so it will have to be on the y direction. And for it to go to any of this direction, if we have that force, we have to come from negative y direction. And that concludes my exam number 5.